Hello, in this video, I'm going to solve another level physics. So, this is question number. While investigating the projectile motion, a student used stroboscope photograph to determine the position of a street ball at regular intervals as it fell under gravity. With the stroboscope flashes 20 times per second, the ball will release from rest. So it means the ball was released from rest, means the initial speed of the ball was equal to 0 at the top of an inclined track. Here is the inclined track and left the foot of the track at P. Okay, so it means the ball will release from the top and it will go to point P, and then it will covers a distance, horizontal distance, that is equal to x, and the vertical distance, that is equal to y. Okay, for each of the image of the photograph, the student calculated the horizontal distance and the vertical distance. So this there is a measurements that the student took here. Below is the table that shows the values of x and y and the t, mean the horizontal distance covered by the ball and the vertical distance covered by the ball, and corresponding the time. Okay, so now we have to find the using two set of measurements from the table, calculate the horizontal component of the velocity of the ball. We have to calculate the horizontal. Okay, first of all, I will explain the motion. Okay, for example, when the ball is released from that point, okay, it will go down. Okay, it will go down and it reaches at point P. So when it reaches at point P, it has two components, that velocity x component and the velocity y component. At any motion and at any point, it has two components, x component and the y component. Definitely x component throughout the motion remains the same. There is no effect on the x component, but the y component increases from top to bottom. Now when the ball is released from here, okay, so it will go down and it will cover a curved path, and it will be at the point at this position, that is the final point. Okay, so final point is here. Okay, so we have to find the horizontal component of the velocity. So we have the data x and y values, horizontal vertical distance values for the different points. So first of all, we have to complete this table. So this table says we have to find the position y divided by t. So we have to divide these 2 points, y by t. 9.3 divided by 0.05, it will give us 186. Similarly, we divide 21 by 0.10, it will give us 210. Next, 250, 233. Next, we divide y by t, we get 259. Next, we divide and we get 284. And similarly, and finally 92 by 0.3, we get 307. So we complete this table. Okay, now in order to find the horizontal component of the velocity of the ball, as we know that we have different values of x and t. Horizontal component is actually equal to ux equal to horizontal distance divided by time taken. So actually we have taken the photograph at different time intervals. So we just divide the value of x with t, in order to get the horizontal component. So 11.6, this value divided by 0.05, we get 11.6 divided by 0.05, we get 2.32. Similarly, 22 divided by 0.10, we get 2.20. Similarly, next we get 2.16. Next we get 2.21. Next we get 2.20. And finally, when we divide 66 with 0.30, we get 2.2. So we take the average of all the values, because this is the horizontal component at different intervals. So we took the average value. So when we took the average value of the x component equal to, we add all the values, 2.32 plus 2.20 plus 2.16 plus 2.21 plus 2.20 plus 2.20, and we divide the number of values, that is the 6. So we get, our answer is 2.21, and we round off and we get the answer 2.2. for the two significant figures. Okay, with the accuracy of plus minus, we know that this is the average value of the speed, horizontal component velocity. So its uncertainty is, because as we know that this is 2.21, so uncertainty is 0.05 plus minus. Why it is 0.05? Because it's, if our answer is 2.2, if our answer is 2.3, so there is a uncertainty of 0.05, because if our answer is below this fourth line, 1 2 3 fourth, 2.1, 2.2, 2.3, 2.4, so we retain this previous answer. If our answer is 5 or above this 5 line, we get return to the next point. It means there uncertainty of 0.05 below and the after. So our uncertainty is 0.05, so it means our answer is 0.05. So we have to also explain the reason for the choice of the measurements. Okay, in order to explain this, actually, because we can explain this, the larger values in this data than the horizontal component, larger values are the more accurate, mean 2.32 are more accurate than 2.20. We have to explain this reason for that. Larger values are more accurate, okay, and larger value more accurate, and the use of differences use of differences to eliminate zero error in this measurement, because every measurement have some error. So this error is known as zero error. This zero error is due to any instrument or device uncertainty. Every instrument is uncertain to a limited value. Okay, so if we want to remove the zero error or uncertainty, we should have to take the difference of the errors. Okay, so we have to remove the error by the taking the difference with the zero error. Okay, now for the part B, the student work out that variable y and t are experienced can be represented by the equation. So here is the equation, that is y over t is equal to u plus kt. This equation looks like just like a equation of a straight line. That's just like a y is equal to uh, c plus mx, where x and y are the x and y points, x and y coordinates, and c is the y intercept. X and y are x axis and y axis. Okay, and m is the slope or gradient. Okay, so similar equation, that is equal to y over t is equal to u plus kt. So here we can see that y over t is the y axis, in our y axis is y over t, and on x axis we have time, that is represented by t, and u is the y intercept, u is the y intercept, k is the slope, k is the slope okay. Now we have to complete the table. I already complete the table because I divide with the y over t, so we get these values, and ux is the average. We can find the initial horizontal speed in the rough work. Okay, we don't, if we don't want to include in this, so we can just rough work, and then we have the explanation like this. Okay, now use the data in the above table, plot the suitable graph. So I have to draw the graph. Okay, so we have the table values, because on the y-axis we have value y over t, that is this column, that is the y-axis. On the horizontal axis we have the time, x-axis is the time. So we have to draw the graph, okay, between these two table, last two columns. Okay, so I draw the graph between these 2 points. Okay, so our first value is 0.05, and our first on the y-axis we have the 186. So this is our first point, that is 0.05 into 186. This is second point, that is equal to 0.10, 0.10 and 210. Similarly, we have different points on the 0.15, 15, and on x-axis and the y-axis we have values of that is that is equal to 233. Similarly, 0.20, this point is 0.20, x-axis and y-axis has value of 259. So similarly, our last point is 0.30, and we have value of 307. Okay, I draw the graph. Okay, now the graph should be straight line, because this is a equation of straight line. So in order to find the straight line, we just minimum 3 to 4 points that the equation for that the best fit line. We have to draw the best fit line. Best In order to draw the best fit line, we have must need 3 to 4 points. Okay, so I can see that these 4 points, 1 2, these 4 points are just like a straight. Okay, these are straight. Okay, and we retrace these lines. Okay, so we get the we get the straight line. This is equation of y over t equal to u plus kt. Okay. Okay, in order to find the y-intercept, what is y-intercept? First I explain what is y-intercept. Y-intercept mean value of y-axis, value of y-axis when x equal to 0. Here on the, we know that y on the y-axis we have value y over t, so it means we have to find the y over t value, when time t equal to 0, when time value equal to 0. So it means we have to retrace this graph. Okay, so if I'm more sure, so I here is the graph, that is the almost 162, or 162, 162, 162. So this is the point, of that is the y-intercept. U is equal to 162. This is centimeter per second. Okay, so this is the y-intercept. Okay, now I move forward and explain more. Okay, here is the graph is done. Okay, use the graph to find the value of u and k. So in order to find from the graph, we know that value of u is the y-intercept, that is equal to 162, and the value of k is the slope of the graph. We can find the slope of the graph. Okay, so slope of the graph, in order to find the slope, we just take the difference, and we take the difference that is equal to means slope, in order to find the slope. So slope is equal to del y over del x. Okay, so delta y is when we find the difference between the y points, that gives us, and when we draw the difference between y and x point, we come to know that our slope is 495. 495 slope will give us 495 centimeter per second, per square. We can find the slope between y points 307 and 307 minus 186, divided by 0.30 minus 0.05. So we take the y difference and divide it by x difference, mean y axis, and divide it by x axis. So we get the slope, that is 495 centimeter per second inverse. Okay, now, okay, you state the physical significance. So what is the physical? U is basically, u is the initial vertical component of, u is initial vertical component of velocity. K is equal to first of all we have to find the k. So in order to find the k, we just compare this equation, y is equal to mx plus c, and or c plus mx. actually if write y is equal to c plus mx. Okay, now we have value just like same equation y over t, we have equation y over t is equal to u plus kt, u plus kt. Okay, now for the y-intercept, as we know that for the y-intercept, so value of y-intercept is when x equal to 0, mean initial we have value of y over t value. So we have to put the this u, because at the starting point y component of the velocity is 0, initial vertical component of the velocity is 0, uy is equal to 0. So our equation comes to now v y over t is equal to kt. Initially the y component of the velocity must be 0, so y over t is equal to kt. So here we can find k is equal to y over t square. Okay, so this is I think equation 1 for example. So as we know that we can also write second equation of motion, equation of motion, that is equal to y is equal to ut plus half at square. So this is y component, so initial vertical component is 0, this component is 0, so y is equal to 0 into t plus half at square. So y over t square equal to half a, that a is equal to g, we can see that y over t square is equal to half g. So so we can replace this equation 1 now from equation 1. From equation 1 we know that k is equal to y over t square, k is equal to, and y over t has value from the equation 2, we know that y over t square is equal to half g. So our k equal to half g, it means the value of k is the half of the gravity, k is the slope, that equal to half g. And we also know that half g is 9.8 or 980. So if we come to note that half of this 495, that is the value that we have found in the slope, 495, the exact value, same value. Okay, calculate the magnitude of velocity at point P. So in order to find the magnitude of the velocity at point P, so first I will redraw the graph, redraw the figure, sorry. So here is the y distance, here is the x distance, curve path. Okay, now when the bar slides down, okay, when the bar slides down, it has both component, throughout the motion it has both component. So at this point P, it has two component, that y component and the x component. So x component we have already found, that is equal to ux is equal to, we already have found the x component, that is equal to 2.2 meter per second. So y component, initial velocity y component equal to, we have to find the y component. So at this point the uy is equal to actually the y-intercept, that is the y-intercept, uy is equal to, that is the y-intercept that we already found. Okay, y-intercept is equal to 162, 162. So if we divide with the, divide with the 100, we get meter per second, that is equal to 1.62 meter per second. So vertical component of the y-intercept is actually the vertical component, as already we discussed that vertical component. Okay, so if we have the x component, if we have the y component, so we can find the magnitude of velocity by using the this formula. Yeah, as we know that the formula for velocity is equal to under root of x component square plus y component square root. This is the Pythagoras theorem, simple Pythagoras theorem. Here we have if we have two vectors, so this is the resultant vector, so it means this is x component, this is y component. So we use only just Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. So simply velocity v is equal to under root of x component is that is equal to 2.2 meter per second square plus y component is 1.62 meter per second was square. So we solve and we get the final value of the velocity, that is equal to 2.7 2.7 meter per second. Okay, thank you. I think so